Hi and welcome back, and this is a little bit of a lesson on using energy in the environment, and we're looking at energy flow. So let's get on with it. We've already seen that plants are able to turn energy from the sun into a more useful energy that other animals can use. And we've got this radiant energy coming in from the sun, comes into a green plant, and then we have chemical energy in here. Now, we call plants producers because of this, and what they're able to do is to change radiant energy from the sun into chemical energy. And so this would be an energy diagram, energy flow. Now obviously not all of the energy is converted to chemical energy, and there is some energy that is released or wasted, so it doesn't end up with what we've got. And that is typical for any energy change. What we say is this thing is a special process called photosynthesis. Photo equals light, synthesis is about making. So what photosynthesis is about is making something through light. So we're actually making chemicals, and that's really good. So let's have a look at what this is showing us. This thing here is called an equation. It's actually two equations in one. We've got a word equation where we've got the words carbon dioxide and water. We've got chlorophyll here in the middle. We've got sun's energy up the top. We've got sugars and we've got oxygen. Right. So let's go through this and break it apart. In photosynthesis, little things like carbon dioxide and water are made into bigger things like sugars. Now this is the chemical formula for a simple sugar. And we can see that also O2 or oxygen gas is made. Now you might already know that oxygen gas is made, O2, and hopefully we know that water is H2O and carbon dioxide is CO2. Now to do this, these things must be present. Energy from the sun, radiant energy, and chlorophyll, a green chemical in plants. Now all those things are there, then this reaction will happen. Now the funny thing is we have names for this, and I'm going to put them in today, even though we don't have to know exactly them for the test. Over this side, what we start with are called reactants. So in photosynthesis, my reactants are carbon dioxide and water. Over this side, over the right hand side, we always read left to right, are things called products. Now in photosynthesis, the products are sugars and oxygen. And the sugar is stored in the plant. Sometimes it is used in the plant for the plant to grow or repair itself. But that is a slightly different story. So there we go. This is one of the most important chemical processes in nature. And photosynthesis, I'd like you to try to remember this one, and try to remember which chemicals are used and which chemicals are made. And that would be really, really handy. But this energy in plants needs to be used. I mean, we're storing energy in plants, and then this is passed on through food chains. But the thing that releases the energy is a process called respiration. Now in respiration, if you think about it, it's almost the reverse of what we saw there a minute ago. Now respiration is used by every living thing, including plants. Plants have to turn the chemicals they make, the sugars they make, into energy. So here's what happens. In every cell, we find that energy is needed for the cell to keep living. So what happens is sugars come into the cell, oxygen also comes in, so that means our reactants in respiration are sugar and oxygen. Our products are carbon dioxide, water and energy. Or that's what we make out of them. So it's most important. Here, another really important process that's going on, and it is imperative or really handy if you can know this for the test. Now the arrow part here effectively means changes into. So this and this change into this and this. Now remember, when we did chemical and physical change, we talked about reactants and products and things like that before. So none of this should be totally new. Right, so this is the second one, but I think this is the most important part. All living things do it, even plants. So many people think that plants don't respire, they only photosynthesize. No, that's not quite correct. All right, so let's look at it. With the energy we take in, all right, this lucky person has been able to take in chemical energy in the form of carbohydrates, which are things like sugars and breads and biscuits and things like that, fats and oils, which are in a lot of our meats and things, proteins, all these things come into this person. Now I'm using a person as opposed to an animal, but the same thing applies to animals. All right, it comes in, the body releases the energy, and we have a thing called metabolism. Metabolism is using the energy to make the body grow, repair the cells, and be able to move. But while this is happening, we breathe out carbon dioxide, which is a waste, but it still contains energy. We breathe out water vapour. Think about when you're on a cold day and you can see your breath appear in front of your face as you breathe out, the little clouds. That's the water vapour. And we know that we release heat. So this is sort of a wastage period, and this energy we don't use, but this energy disappeared. So remember the conservation of energy. The energy in must equal all the energy that's used and comes out. All right? So let's put that up here, so we'll try to remember it. Energy, oh, goodness gracious me, Mr. Carson, you're getting terrible in your old age with these things. All right, we're just going to get rid of that, and then we'll start again. Energy. Let's see if I can be a better speller this time. Energy in equals energy out plus energy used. And this is why, as I said before, why not all the energy that comes into us equates to energy that things can live on if they prey on us. Because we need to do things with the energy as well. We don't just take it in and store it, we use it for our own uses. Alright, so if we look at that one, then a closer look shows us here. This word here, this metabolism, let's have a bit of a closer look at what it means. Now our lucky girl here, she's seeing that we got oxygen, water, food and chemical energy in the form of food goes into her body, and out comes carbon dioxide. Then of course during daily movement there is sweat and water vapour in our breath. Then of course there is waste products, liquid form, waste products, solid form, and heat energy. Now the total energy here, right, the total energy over here must equal what stayed in here plus all the energy that's in this. And there is energy in it. So we must think about this when we're going through it. I hope that made a little bit of sense.